Greetings and salutations! Today we're going to talk about division, which is the way we're going to find the roots of polynomials. For example, let's say that f of x was x cubed plus x squared minus 33x minus 54. Now, the rational roots theorem, which we'll learn in section 5.5, so next section, is going to tell us how to generate a short list of roots. And if we start plowing through that list, testing to see if any of them work, we might find out, hey, as a matter of fact, f of 6 equals 0. It's 216 plus 32 minus 196 minus 54. That's 0. So now I know that since factors and roots are two sides of the same coin, if 6 is a root, then x minus 6 is a factor. Now, ideally, I'd like to use that information to find out what the other factors are without having to go through the whole process again. So if I could factor out the x minus 6, I'd be in great shape. But how do I do that? Well, that's where division comes in. It turns out that f of x divided by x minus 6 is equal to x squared plus 7x plus 9. If you divide both sides, or if you multiply both sides by x minus 6, that equation becomes f of x equals x minus 6 times x squared plus 7x plus 9. So there's the factorization. And now you can complete the square, use the quadratic formula, or what the heck ever you want to do to find the other two roots, whatever this equation gives you. So we need to work out how to do polynomial division. It turns out it's basically the same as the long division you learned in grade school. Like, let's say I wanted to do 276 divided by 12. I'm going to do two problems side by side, and you tell me how they're similar, right? Then I'd put 276 under the little angle. I'd put a 12 out here, and I'd say, well, how many times does 12 go into 27? And you'd say it goes in twice. 2 times 12 is 24. 27 minus 24 is 3. And then we bring down the 6. Oh, we got lucky. Because 12 goes into 36 3 times. 3 times 12 is 36. And when we subtract, there is no remainder. So 276 divided by 12 equals 23. Now, on the other side here, let's say I wanted to do, this is going to be the same problem almost. Let's say I wanted to do 2x squared plus 7x plus 6 divided by x plus 2. What does that have to do with anything? Well, when I write 276, think of it this way. 276, I'm looking at place values, right? There's a hundreds place. Oh, I want to write 2 hundreds, 7 tens, because there's a 7 in the tens place, and a 6, right? That's what our decimal notation means, is I'm saying how many hundreds, how many tens, and how many sixes. That's the concept of place value. Well, where did we get these place values? They're powers of 10. This is 2 times 10 squared plus 7 times 10 plus 6. Do you see what that has in common with 2x squared plus 7x plus 6? Long division is just polynomial division where x is 10. So the way we carry out this problem looks almost exactly the same. I put 2 in the x squared's place, 7 in the x's place, and 6 in the 1's place. And I divide that by a 1 in the x's place and a 2 in the 1's place. And I say, all right, how many times does x squared go into 2x squared? Sorry, how many times does x go into 2x squared? And you say it goes in 2x times, because 2x times x is 2x squared. So we're going to put a 2x right here. 2x times x is 2x squared, so that matches. So then down here, let me keep a commentary. I wrote, what I'm going to do is put little subscripts, so this is note 1. So this is because 2x times x equals 2x squared. And next what I'm going to do is, in this box, I'm going to do 2x, and I'm going to multiply it. Just like over here, I did 2 times 12 is 24. Over here, I'm going to do 2x times x plus 2, and that's equal to 2x squared. 2x times 2 is 4x. So instead of 24, it's 2x squared plus 4x. And now I subtract. Here's where you want to be really careful. Over here, I subtracted 24. I didn't subtract the 20 and add the 4, just like I'm not going to subtract the 2x squared and add the 4x. I'm going to put parentheses here to remind myself I'm subtracting this whole expression, not just one part of it. You wouldn't subtract one digit and add the other. So 2x squared minus 2x squared is 0, and 7x minus 4x is 3x. And now we bring down the 6. And then I ask, how many times does x go into 3x? And the answer has to be 3. So then just like I did 3 times a 10 and a 2 is 3 10s and a 6, 3 times x plus 2 is 3 x's and a 6. Make sure you put those parentheses. I'm going to draw those in red so we all remember those parentheses are critical, because you wouldn't subtract the 30 and then add the 6 now, would you? And we get 0. Now, you could check with slide and divide, but what we've just learned is that 2x squared plus 7x plus 6 is equal to x plus 2 times 2x plus 3, just like 276 is equal to 12 times 23. And that is polynomial long division. So that's the name of this thing, is long division. And that's all there is to it. Just like 2 times 10 squared plus 7 times 10 plus 6 equals 10 plus 2 times 2 10s plus 3, 2x squared plus 7x plus 6 equals x plus 2 times 2x plus 3. It's practically the same problem. It's just instead of having tens and hundreds and thousands in your place values, you have x's and x squareds and x cubes. Let's do another example, shall we? Now, in base 10, in decimal notation, I'm stuck. These are all numbers between 0 and 9. But in polynomials, I don't have any such restriction. So let's say I had 4x squared minus 3x plus 11, and I wanted to divide that by, I don't know, x minus 2. It doesn't quite make sense to think of this in terms of place values. Well, I've got a 4 in the hundreds place, a negative 3 in the tens place, and an 11 in the ones place. And then here I've got a 1 in the tens place and a negative 2 in the ones place. It makes more sense if you think about the place values as being x's now, but the process is exactly the same. So let me do that. It's going to look just like that example up there. Can I get this all on the same screen? That would be lovely if I could get this all on the same screen. Let's try this and then write, here's x minus 2, here's 4x squared minus 3x plus 11. And then I ask, how many times does x go into 4x squared? And your answer is 4x times. 4x times x is 4x squared. And 4x times negative 2 is negative 8x. Now again, these parentheses are going to be critical. So I'm taking those parentheses. 4x squared minus 4x squared is 0. Now be careful here. Negative 3x minus negative 8x is positive 5x. So don't get fooled there. And now we're ready to bring down the 11 and go again. Okay, next question. How many times does x go into 5x? I'm dividing this into this now. And you say, well, x goes into 5x 5 times, of course. So then I do 5 times x minus 2, and I get 5x minus 10. And then that whole thing gets subtracted. So be real careful here. This is an easy one to mess up. 5x minus 5x is 0. 11 minus negative 10 is 21. Well, x doesn't go into just a 21, so I'd say that's my remainder. My remainder is 21. So unfortunately, this one did not factor evenly. I could say that 4x squared minus 3x plus 11 is equal to x minus 2 times 4x plus 5 plus an extra 21. So these are not factors. They don't correspond to roots because I didn't get a 0 here. So unfortunately, we didn't find a factor, but what we did was we did a division. Just terms for these for later. This fellow's called the dividend. It's the thing you're dividing into. This little guy right here is known as your divisor. These are the same names as in long division, but who remembers that? This thing is the quotient. That's your answer. And the number left over is your remainder. So there you go. Now we're going to learn all the tips and tricks and little loops and tricky bits of division. Then we're going to learn something called synthetic division that lets you do it all way faster. And then we're going to learn the remainder and factor theorem, which is just beautiful. It's a lovely thing. It's a lovely thing. I'll show you that in a bit. For now, let's do more examples. Let's say I wanted to take 3x cubed minus 2x squared plus 4x plus 7. And I want you to divide that by x squared plus 2x plus 3. First step is to ask, how many times does this x squared, I'm just looking at the leading terms. I'm looking at the leading term of the divisor and the leading term of whatever is left of the dividend at whatever step I'm in. So here that's, how many times does x squared go into 3x cubed? And the answer is, if I take an x squared out of 3x cubed, the 3 is still there and there's an x still there. So the answer is 3x. And I'll write that here. Right here. Took a minute. So now what we do is we take this 3x and we multiply it by x squared plus 2x plus 3. And I'll have to distribute to all 3 of those terms. So that's going to get me 3x times x squared is 3x cubed. Good, I needed those to match up. 3x times 2x is 6x squared, and 3x times 3 is 9x. Remember your parentheses. All 3 of these terms are going to get divided. It's just like, or subtracted, my goodness. It's just like subtracting 369. So 3x cubed minus 3x cubed is nothing. Always have to get a 0 right there. If you don't get a 0 there, you've picked wrong. Negative 2 minus 6 is negative 8, and that's in the x squared's place. And 4 minus 9 is negative 5. All we have to do now is bring the 7 down. And now, here's what's left of your dividend. This is a process where you repeat the same 3 steps over and over. You divide, you multiply, you subtract. Now we're in the divide, multiply, subtract again phase. X squared goes into negative 8x squared, negative 8 times. And now we're going to do negative 8 times x squared plus 2x plus 3 and get negative 8x squared minus 16x minus 24. Parentheses, subtract all 3 of those. Negative 8x squared minus 8x squared, or sorry, minus negative 8x squared is nothing. Negative 5 minus negative 16 is positive 11x. 7 minus negative 24 is positive 31. So now I ask, how many times does x squared go into 11x? The answer is x squared don't go in 11x because this fella is degree 2 and this fella is degree 1. 1 is less than 2, so we stop. All right, stop. That whole thing is our remainder. We can't fit x squared into 11x, so our remainder is 11x plus 31. And we're done. I'd say that this whole fella is equal to this thing times this thing plus that thing. Let me write that down. This whole fella is equal to x squared plus 2x plus 3 times 3x minus 8 with an extra 11x plus 31 on the outside. And that's the way the news goes. One thing I want to point out here, and this is really cool, is the columns in this problem. Look, all down here, everything under the bar, these are all x cubes. And all 4 of these are x squared. All 5 of these are x's, and all of these are ones place. So there's a column for the ones place, a column for the x's place, a column for the x squareds place, and a column for the x cubes place. You have to keep the place values in their columns. Watch. Here's where you can run into trouble. If I wanted to do x to the 4th plus 4x plus 7 and divide that by x plus 1, I can get in some bad trouble right now. I can say x goes into x to the 4th, x cubed times. Multiply, x cubed times x is x to the 4th, x cubed times 1 is x cubed. These fellows right here do not match. I've got an x cubed in the x's column. What in the world? What happened? This is awful. What I need to do is respect that there's supposed to be an x cubes column. So I'm going to set up this polynomial with missing terms in x cubed's place with nothing in it, in x squared's place with nothing in it, and then a 4x and a 7. Into this fella, I can divide x plus 1. So x plus 1 goes into this whole thing, and now when I say it goes in x cubed times, and x cubed times x plus 1 is x to the 4th plus x cubed, now when I go to subtract, I got my x cubed in my x cubes problem, in my x cubes column. So no x cubes minus 1x cubes is negative 1x cubed. I bring down the 0x squared. And now loop it and scoop it. X goes into negative x cubed, negative x squared times, because x times negative x squared is negative x cubed. 1 times negative x squared is negative x squared. This whole fella gets subtracted. Negative x cubed, This times that is that. Whole fella gets subtracted, not just one part. So we get 0 here, and we get a positive x squared here. Now we bring down the 4x. X goes into x squared x times, because x times x, come on, x times, because x times x is x squared, and x times 1 is x. Now I subtractify and get a 0 here and a 3x right there. Finally, I can keep going because x still goes into 3x, so I'll bring down the 7. And x goes into 3x 3 times. 3 times x plus 1 is 3x plus 3. Subtract that whole thing, and you just get a 4. So when we're all done, the remainder is 4. But we can't make any progress until we respect the missing place values. Because if I had x to the 4th, 10 to the 4th is 10,000. If I wanted to write 10,047, we wouldn't have this problem. This looks like the problem 11 divided by 10,047. And we're used to writing those zeros there. We're used to putting zeros in missing place values. That's why this still works, and you didn't have to learn this in grade school. You wouldn't write this 147. That would be 147. That's a different number. So in the same way, you wouldn't write this without these guys, because the next values would be missing. See how nice it is? Now all the fourths, thirds, seconds, firsts, and nones line up. So that's how we get the correct answer. Let's try another one. Again, we got to respect our missing place values. So if I tell you to divide 4x to the fourth minus 4x squared plus x plus 1 by, how about 2x squared plus 3? We're going to want to show some respect for them missing place values. Where are they? We're missing a cubed place here, and we're missing a x's place here. So when I set up this problem, I'm going to say 2x squared plus no x plus 3 be going into 4x to the fourth, 0x cubed minus 4x squared plus x plus 1. And now I can proceed. And so I do. You can follow along at home. 2x squared goes into 4x to the fourth, 2x squared times. Then we multiply this fella by all three of these. I'm going to get a 4x to the fourth here. Nothing in the middle, so I'll skip it. And 2x squared times 3 is 6x squared. You see how it's a 0, so I'm just not going to write it, okay? Then I get a 0 here, and a negative 10x squared here, because this whole fella's in parentheses. I'll bring down my x and my 1, and go again. 2x squared goes into negative 10x squared, negative 5 times, because negative 5 times negative 2x squared is negative 10x squared. Then there's nothing in the middle, and a negative 15 out on the end. When I subtract that whole fella in parentheses, so a negative 15, nothing in the middle, negative 15 out here, I get a nothing, I get an x, and I get a plus 16. Now this is a smaller degree. This is degree 1 and that's degree 2. So 2x squared don't go into x, so that's my remainder. I could write that 4x to the fourth minus 4x squared plus x plus 1 is equal to 2x squared plus 3 times 2x squared minus 5 plus x plus 16. And that's that. Join me in the second part of this 5.4 video, and we will we'll learn a quicker way to divide. And then we'll learn the theorem, the factor theorem, the real cool remainder and factor theorem.